Hello, imagine if you could set up your own observability system in your own Kubernetes cluster that is extremely efficient. Okay. Can use object storage for super cheap storage. Okay. You can set it up in under 5 minutes. Okay. And provides you all the features around logs, metrics, traces, alerting, dashboarding, and a whole lot more. That is exactly what OpenObserve is. And today we will learn how to set it up in your own Kubernetes cluster in Google Cloud. Yeah. We'll use GKE, where I have a cluster. We'll use GCS, Google Cloud Storage, for storing the data. Okay. So how do we get started? Let's first go to the documentation. You'll learn that under Quick Start, there is a way for you to do a self-hosted installation. And there are multiple ways in which you can do it for multiple platforms. However, everything that you see on this particular page allows you to do a single node installation, which can actually work well for many teams and organizations, considering a single node of OpenObserve can ingest and provide you all the capabilities for up to a terabyte of data ingestion of per day. Okay. But if you want a highly available environment of OpenObserve, and your data ingestion requirements and storage and search requirements are much higher, then you would want to go ahead and do a highly available deployment. And this is what we will do today. So the highly available, while Kubernetes is not a requirement for setting up OpenObserve, Kubernetes definitely makes it easy to set it up. And we use Helm charts to set up OpenObserve. So the way Helm charts work is that Helm charts has a configuration file where you set up details before you can go ahead and do the installation. And this repository is the source code for OpenObserve Helm chart. Okay. If you go to the charts folder, you will see that there are 3 folders. OpenObserve, this is the highly available OpenObserve. This is a single node OpenObserve Helm chart. This is for OpenObserve collector. We are concerned about OpenObserve here, which is the highly available Helm chart. Okay. And specifically what we'll be looking for is the values.yaml file here. This is the file which contains all the configuration that we will use for installation. Yeah. It's a pretty long list of configurations that are available. However, there are no more than 3 to 5 settings that you need to do for a highly available installation, and we'll take a look at those things. But as a first step, let's go ahead and download this particular file. You can download this file from the GitHub here. You can actually run this curl command here. So I'll just copy this and run this. And it'll download this values.yaml file for me. So what are the things that I want to do? This is the first thing that I have downloaded the values.yaml file. Second part, essentially metadata store. Whenever you store data, any logs, metrics, or traces, they'll be stored in the object store, which is Amazon S3, Google Cloud Storage, or Azure Blob Store, or MinIO, or some other location. The data regarding which files are there and what location, whether it pertains to logs, metrics, traces, or something else, all of that information is stored in the metadata store. And you can use either Postgres or MySQL. We generally recommend Postgres for that. And if you're setting it up for production, for the most part, I would recommend that you use managed Postgres from any of the cloud services or from which is Amazon, Google, and Microsoft. And there are others as well who provide you a managed Postgres service. However, to make it easy, OpenObserve Helm chart also provides you a bundled cloud Postgres called Cloud Native PG. So Cloud Native PG is a Kubernetes operator for setting up and managing Postgres in your Kubernetes cluster. So in this demo, we'll use this. And this is a lot of people run their production deployments using Cloud Native PG as well. So if you're able to manage this well, if you understand it well enough and are setting up backups, ensuring scalability, you will actually be fine even with this. So let's move forward. So we'll not set up metadata store in this case, in this demo, and it will be automatically be set up by the Helm chart. Second comes configuration. And we will be setting up our OpenObserve in a Google Cloud Storage. So what are the things that we need to do? We need to set up authentication and certain configuration. Okay. So let's take a look. First thing, this is our Kubernetes cluster. It is in US Central 1C. That's the US Central 1 is the region, and US Central 1C is the availability zone. Let's first go ahead and create a bucket where we will store all the data. Let's call it O2 hyphen some random number. Let's not do multi-region. Let's select the region, US Central 1. Make sure that the region is same as that of your Kubernetes cluster. Otherwise, latencies for read and write can be extremely high. And let's continue. Enforce public access, which is perfect. We don't really care about soft delete policy. Let's go ahead and create this bucket. So we have a bucket here. Let's use this bucket name. Let's go to our values.yaml file. So on line number 266, 0 S3 bucket name. Let's paste this over here. The S3 provider here, let's take a look at S3 provider. Here is S3. Region name is auto. Region name, let's select auto. Okay. And bucket name we have set up. Let's set the server URL here. And so how do we get these two? Let's go to buckets, settings, and let's go to interoperability. And let's scroll down. There's a section, access keys for your user account. Let's go ahead and create a key. This is the key that you'll use, access key. And you'll see this, you'll put this in the auth section here. Auth section, access key, and secret. Yes, we are good here. And these are the initial credentials for logging on to OpenObserve. Give it whatever email ID that works, your email ID here. And let's call it super complex. Pass hash 1 to that. That'll be our password. Okay, so while this is sufficient, all of this that we did is sufficient for us to set up OpenObserve. But a little bit more here. Okay. Now, when you set up a service in Kubernetes, by default, it is not accessible outside of the Kubernetes cluster. In many scenarios, that is an ideal situation, ideal thing. But in our case, we want to use or access our OpenObserve cluster from our laptop. Okay. and we'll be installing OpenObserve in Google Cloud. So how do we do that? Ideally speaking, let's search for something called ingress. Ideally speaking, you generally want to set up something called an ingress, and this is a Kubernetes concept. There are different kinds of ingress controllers that are available. Nginx is the most popular one that you can use, and it'll set up a load balancer for you. It'll allow you to set up SSL, HTTPS, okay, and a whole lot of other configuration is available. But setting up an ingress at this stage for this demo is out of scope, because then you'll have to deal with DNS and whatnot. Uh, we don't really want to do that. What we'll do is that we'll set up the Kubernetes service to be accessible from outside the Kubernetes cluster. So by default, the service type is cluster IP, which is accessible only inside the Kubernetes cluster. If you set it up to type load balancer, it becomes accessible from outside the cluster. And with this, we are ready to set up OpenObserve. So how do we do this? Now that we have done the configuration, let's go to setup. The first thing that we need to do is set up Cloud Native PG controller. Yeah. I have already set it up, but this is just one line command that you can execute, and your Cloud Native PG controller will be up and running. Then next part is you just copy these couple of commands. This one will add. Okay, so you must have Helm installed on your laptop for you to be able to do this. So add this particular repository to your Helm, update it so that Helm will essentially download the chart and keep it in the local cache. And then let's create a namespace called OpenObserve, and this line will essentially go ahead and install it. All of this is preparation. All of this is literally preparation. This one-liner is going to install things. And I've already done this in the past. So, and these two, in fact, let's copy all of this and run this here. Okay. So what is happening is, if you see, Helm minus namespace OpenObserve. So it'll install OpenObserve in this particular namespace, and minus f values.yaml. It'll use the values.yaml file, the one that we created and configured, and install. And O2 is the release name. It's a Helm concept, and then this is the chart repository chart. Okay, so let's go ahead and run this. Okay. And namespace created, and this is done. Okay, so k get ns. Let's do this. So k stands for kubectl here. If you are using kubectl, then you can use this. The way to set it up is alias k equals kubectl. Okay, if you do this, you'll be able to start using k from now on. Now we have a namespace here, OpenObserve. So k minus n OpenObserve get peer. So pretty much all the pods are up and running except for this one. Now this is the Postgres second pod. Okay, so Cloud Native PG will set up Postgres in high availability mode with two pods. Okay, so if one of the pods goes down for whatever be the reason, another pod will be available and it will take over. Okay. Let's run this once again. This is still running. Okay, let's do a watch kubectl. So when you run things with watch, it does not honor aliases. So I had to type the full name, but since everything is now up and running. Courier, this is not running. Why do we have a 0 here, 0 of 1? containers. We need a courier before we can start using it. So let's wait for this. Okay, this is up and running. So we should be fine. So NATS that you see here, NATS is the message broker that allows coordination within the cluster. Yeah. So all the nodes that join OpenObserve nodes, like your ingester, compactor, alert manager, courier, router, they pass messages to each other and get to know about each other via NATS. So NATS is extremely important component here. Yeah. K-n OpenObserve get SVC, get services. So remember we set up this type as load balancer. What this did was it created a load balancer in Google Cloud, and this is the external IP of that. Okay. Now we can use this external IP of router. Let's take this and access it, our OpenObserve instance. Okay, 5080. And we are done. That's all it takes to set up OpenObserve. Remember, this is standard HTTP, and in user ID and password that you type here will go over, will go unencrypted to the internet. So you do not really want this. Ideally, you would want to use an ingress, okay, and set up TLS either by ingress mechanism or any other mechanism, but we just don't want it to be unencrypted. But since this is a demo, we'll go through this. Let's use the user ID and password and log in. This was the user ID, and this was the password. So this user ID and password is used only for the at the time of creation. Now once you're here, you can actually there's if you change the password, okay, then you'll be able to go ahead and this password will not really be applicable. Okay, and you'll be able to go ahead and change that via users IAM section here. Okay, but this is where your installation ends. Okay, and we'll stop here for today and have a good day ahead.